This is OTDR carrying bag. In the package, there are OTDR, calibration certificate, user manual, power adapter, U-disc touch pen, SC adapter for OTDR port, SC adapter for OPM port, USB DIN line, wrist belt. The OTDR is touchscreen. It can be operated by touch pen, by button, or by finger. OPM port, Wi-Fi port, optional OTDR port for multi-mode fiber, OTDR port for single-mode fiber. Light source ports are the same as OTDR ports. USB port, power charging port, Ethernet port, micro USB port for exporting data. There are 9 functional modules: OTDR, light source, Wi-Fi, OPM, event map, IoT cloud platform, FEI, fiber interface inspector, OLT, optical loss test system. Here are OTDR, 2 fiber spools. This is 20 kilometers. This is 10 kilometers. Click OTDR module to enter OTDR testing. Click Set to set testing parameters. Click Wave to select testing wavelengths. There are 1310, 1550, and 1310 and 5050 nanometer. We select 1310 and 1550 nanometer. The testing will be tested at the 2 wavelengths at the same time. For mode, there are 3 testing modes: auto test, real test, average test. For new engineers who do not have any idea on OTDR testing, you can select auto test. Real test is to dynamically monitor fiber link. Average test is for experienced engineers to improve the testing quality. We select average test. PAN module is for testing PLC splitter in PAN system. For range, we select 64 kilometers. This value is 2 times of the fiber length. We have 2 spools. One is 10 kilometer and the other is 20 kilometer. So we select 64, around 2 times of 30 kilometers. Pulse. For short distance, we select narrow pulse widths. For example, 160 nanosecond. For long distance measurement, we select wide pulse widths. For example, 3000 nanosecond. Okay, for 30 kilometers testing, we select for example 320 nanosecond. fill in average time. For example, 30 seconds. Click OK to enter the value. IOR is index of relative helix. The two values we have to ask from the fiber manufacturer. IOR value affects the measurement fiber length, and we have put default value 1.468 for IOR, 1 for helix. For event loss threshold, return loss threshold, and end loss threshold, we also fill in the default value. For lock A and B, if we select lock A and B, it means we can move cursors A and B at the same time. If we do not need it, we do not select it. Click OK to confirm the setting. Click Test to start the testing. Wait about 30 seconds. Okay, the testing is completed. For this line, it is the total link loss between cursor A and cursor B. The total loss is around 10 dB, and the average loss between cursor A and cursor B is 0.341 dB per kilometer, and the total distance is about 30 kilometers. For this line, wavelength, range, pulse, IOR, it is the testing condition. Here are the detailed event information. This is the first event. This is the second event. It shows the distance, loss, and the total link loss. For the second event, the distance is 30 kilometers. The return loss is about 31 dB, and the total link loss is about 10 dB. Click File to save the curve. Click Save. Fill in file name like OTDR. Select file path. We can select memory or USB disk. Okay, we select OTDR memory. Also, we can select fast save and auto save. For fast save, the file name can be named by time or by name. For example, if we select by name, for the next OTDR testing, the file name will be OTDR1 and then OTDR2. For autosave, we can select by auto test and by all test. If we select by auto test, it means the testing is under auto test mode. If we select by all test, it means the testing is under auto test mode and average test mode. Click the right direction to the next page. We need to fill in cable ID. For example, 2 and the cable code 2 and fiber ID 10 and the data flag. BC is newly built fiber cable. RC is the repaired cable, and we can select the others. This is the start location, and this is the terminal location. For example, for the start location, you can fill in central office, CO, to terminal box. Click the right direction to the next page. We need to fill in operator name and the user offset. For the fiber type, we need to select the fiber type, the multi-mode fiber, the single-mode fiber, and the dispersion shifted single-mode fiber, and the non-zero dispersion shifted single-mode fiber. For this fiber, we select 652 conventional single-mode fiber. For the comment, we can input pass or fail. If the testing passed, we need to fill in pass. Click Save to save the file. Click File to open it. This is the testing OTDR. We can click Read. Okay. Also, we can copy the file to UDisk. Okay. Click this one and mark it. Click the right direction. Okay. This means the OTDR file is copied from memory to this UDisk. Also, we can click Delete. If we want to delete OTDR data from UDisk, we select it, mark it. Here, there is a star, and then click Delete. Okay, it disappears. Click Return. Click Analyze. Click Condition. We can see the testing link information here. Click Event List to go back. Click Event Add. Select Down Event or Up Event or Reflect Event. We select Reflect Event, for example. Right now, cursor A is in red. It means it is selected. We click on the screen. For example, right now it is at 15 kilometers. Okay, the distance changes according to the position of cursor A. Click Add. This is the first event, which we added just now. And right now there are 3 events. We can also click Event Change and Event Delete. For example, we delete the first event. Right now there are 2 events. Connect U-disk with computer. This is OTDR Analyze software. Click File. Click Open File. Select OTDR SOR file and open it. This is the saved code. Click File. Click Preview to preview OTDR test report. Close it. Click File. Click Print to print OTDR test report. This is printed OTDR test report. This is optical parameter OTDR reference patch code on test SC adapter. For OTDR, click US module to enter light source mode. Turn on 1550 nm light source. For optical parameter, press wavelength button to select the same wavelength, 1550 nm. Insert reference patch code into light source port. The light source port is the same as OTDR port. And insert the other side into OPM. Press dB button to 0. It shows 0 dB. Press again. Okay, 0 dB. Take out SC connector from OPM and connect with patch code on test. The insertion loss of this connector is 0.15 dB. Click Wavefill module. Insert FC connector into Wavefill port. Click Normal. Here, normal is continuous wavelength. Or change it into 1 Hz. The light will flash. 2 Hz. It will flash quickly. And close Wavefill. This is optical light source, OTDR, reference patch cord on the test, SC adapter. Press wavelength button to select wavelength 1310 nanometer, for example. Click OPM, click wavelength to change it into 1310 nanometer, the same as light source. Connect reference patch cord with light source and OPM port in OTDR. Click Start. Click Reference. The relative power changes into 0 dB. Take out SC connector from OPM port and connect with the patch cord on the test. The insertion loss of this connector is 0.04 dB. This is OTDR, this is ONT, this is FTTH drop cable. OLT at the central office is transmitting optic signal right now. Insert SC connector into OPM port. Click OPM. Click wavelength to select 1490 nanometer. Click Start. The receiving power is minus 13.6 dBm. The receiving sensitivity of our ONU is minus 27 dBm. The receiving power of minus 13.6 dBm is much higher than the sensitivity power of ONU, minus 27 dBm. So it's okay for our ONU working. This is to test 1 to 16 PLC splitter. This is OTDR. This is 10 km fiber spool. This is 20 km fiber spool. This is 1 to 16 PLC splitter. Click event map. Click set to set the testing parameters. For wavelengths, select 1550 nanometer, for example. For mode, select average test and select PAN module for PLC splitting. For the range, select 64 kilometers. For the pulse, select 80 nanoseconds. For average times, fill in 30 seconds, for example. Click OK to confirm the setting. Click Test to start the testing. Wait 30 seconds. Here are the total link information. The test condition is single mode 1550 nanometer. The fiber length is 30 kilometers. The total link loss is about 17 dB. There are two events. This is the first event, the PLC splitter. The loss of the PLC splitter is about 12 dB. This is the second event, the fiber end, 30 kilometers. Total loss is about 17 dB. Click File to save the data. Fill in file name, MAY Telecom for example. Select file path, we select memory. Click the right direction. Input cable ID 1, 2, 3, 1, 3. Okay. Input the cable code ABC. Input a fiber ID 12. Input the data flag. BC means the newly built fiber cable. The O location and the T location. This is the start of the fiber. For example, home. This is the terminal location. Cabinet 1. Click the right direction. Fill in operator, Philip for example. Select the fiber type. We select 652 conventional single mode fiber. Fill in comment. Fill in paths for example. Click Save. Click IoT Cloud Platform. This module is not authorized. It is optional. Click FEI. FEI is Fiber Interface Inspector. It can inspect fiber interface quality. Used together with optional Fiber Inspector probe. Click OLT module. OLT is optical loss test. This is standard patch code. Insert it into laser source port. Laser source port is the same as OTDR port. Insert the other side into OPM port. Click the wavelength and select 1550 or 3010 nanometer. We select 1550 nanometer. Click Start. Okay, the insertion loss is 0.34 dB. When the output power is stable, click OPM reference. The insertion loss changes into 0 dB. Take out the SC connector from OPM port. Connect it with the fiber spool. Insert the output connector of the fiber spool into OPN port, and the insertion loss of the fiber spool of 30 kilometers is 6.66 dB at 1550 nanometer. Click System module. We can see software version. Click System Set. Click System Help. There are help files like how to use OTDR, how to manage OTDR files. And click Update. We can download and copy the upgrade software into UDisk and attach it to USB port of OTDR, and then upgrade the software.